Good day everyone. Welcome to my channel where physics learning is highly possible and important to the author. Aside from finding micro solutions for problem of food shortage, even in the city, through urban gardening. He is also trying to make learning physics easier for everyone, despite of the present condition where face-to-face classes are not allowed and teaching and learning could be safely possible through online virtual classes only. Today in this session, a virtual experiment about friction will be performed. I hope that you will attain the objectives of this experiment and learn the topic through this experiment. The objective of this activity: to determine the coefficient of static friction between two wooden materials. To obtain this objective, materials required are the dynamic kit stand, the digital balance, a ruler, a pulley, coins, wooden cart, thread, and the weighing pan. The theory behind this experiment: by definition, the coefficient of static friction between two solid objects in contact is the ratio of the frictional force to the normal force between the objects when relative motion between them impends. When an object, the carrier in this activity, is pulled along the horizontal surface of the kit stand, a frictional force resists this pull in the opposite direction. In figure A, you can see the wooden cart, the dynamic kit stand, and the pulley system. Take note that the wooden cart and the dynamic kit stand surface are horizontal. To determine the coefficient of static friction between the carrier and the horizontal surface of the kit stand, both are made of wood. The pull on the carrier is considered as equal to the magnitude of the frictional force if the carrier just starts to move due to this pull. As shown in the figure, this pull then is equal to the weight of the pan and its contents, while the weight of the carrier is taken as the normal force. In figure B, the surface is inclined. The figure shows the dynamic kit stand, the slider that makes the surface inclined, with points A to B as the height of the slider, and points A to C is the distance from the slider to the end of the inclined plane. For the inclined plane, the component of the weight of the carrier along the incline is considered as the frictional force if the carrier just starts to slide down, while the component of the weight of the carrier perpendicular to the incline is taken to be equal to the normal force. The following procedure will be followed in performing this experiment. The first part of the experiment, when the surfaces are horizontal. Set the pulley at the end of the box cover of the dynamic kit stand as shown in figure A. Hook the shorter cord on the carrier and hang over the pulley the weight pan from the cord's other end. Adjust the position of the bent shaft of the pulley to make the direction of the cord from the carrier parallel to the horizontal box surface. Slowly put weights and coins on the pan so that the carrier will just start to move. Place a weight between the wheels of the carrier Then repeat step number 2 for 3 more trials by adding 1 more weight on the carrier for each trial. Compute the coefficient of static friction between the carrier and the box cover by dividing the weight of pan and load by the weight of carrier and load. Record and complete the table. Part B. When the surface is inclined. Remove the pulley system and pan from the dynamic kit stand. Incline the box cover by using the wooden support, initially at the leftmost end of the box cover. Then move the support slowly toward the right until the carrier just starts to slide down the incline. From figure 2 below, measure the rise AB and the run AC of the inclined box cover. Record data in Table B. If you need the figure or the setup, you may turn back for the slides earlier. Add one weight between the wheels of the carrier and repeat steps number 2 and 3 for 3 more trials, adding one weight each time on the carrier. Divide the rise by the run of the incline for each trial. Record in complete Table B. The next slides are video clips and pictures or photos where you will collect the data for this experiment. So be ready with the activity sheets, pen or pencil, paper, and your calculator. If you need more time for measuring and reading the dimensions, you may pause the video. This table is the same as the table on your activity sheets. So you are going to perform 4 trials for each part of the experiment. So here in this table, you're going to record the weight of the carrier plus loads in dynes. The weight of pan plus load also in dynes, and the weight of pan and load divided by the weight of carrier and load, and determine the average of static friction for the 4 trials. Table B is for the second part of the experiment. You're going to perform 4 trials. So you measure distance AB as the rise in centimeter, and measure distance AC, the run, also in centimeter. Then determine the ratio of the rise over the run. Calculate the coefficient of friction for the 4 trials. The third table summarizes the averages for part A and part B of the experiment, and then calculate the percent difference using the given formula. So this is the setup for the first trial. So the carrier is on top of the box. Slowly put coins into the weighing pan. You have to do this slowly to avoid the effect of the velocity of fall of the coins in the pan until the carrier starts to move. Then measure the masses. So the mass of the carrier, in the first trial, there's no load. Record. The weight of the coins and the pan. Record. For the second trial, this is the setup. Now add one weight on the carrier and slowly put coins into the weighing pan. You have to drop slowly to avoid the effect of the velocity of fall. Continue dropping coins until the carrier starts moving. There. Then you have to weight the carrier plus load. And the pan plus load. And then record on the table for trial 2. Now for trial 3. Add one more weight on the carrier. And slowly drop coins into the pan. The same with the previous trials, you have to do that slowly until the carrier starts sliding over the surface. Then take the mass of the pan plus load and the carrier plus load. Record on the table. Trial 4. Add one more weight on the carrier, making it 3 for weights for the fourth trial, and slowly drop coins into the weighing pan. Until the carrier starts sliding over the surface. Then record the mass of the carrier plus load and the mass of pan plus load. Note that what you have measured are in grams. What is required in the table is the weight in dynes. So you have to multiply the mass by the acceleration due to gravity, 980 centimeters per second square, to obtain the weight in dynes. Now for part B of the experiment, for trial 1, the setup, the wooden carrier is on top of the surface that is inclined by the slider. Now the slider will be pushed to the right until the carrier starts sliding over the inclined surface. Now the rise and the run will be measured using a ruler. So this is how to measure the run from point A to point C, referring to the figure B in the previous slides. Okay, so let's measure the rise. So using this ruler, let's expand the view so we can read it clearer. Now read the distance from point A to point B and record as the rise. Take note that the rise for all trials from trial 1 to trial 4 will be the same. This time, read the measure of the run. If you need more time, you may pause this video. Now for trial 2. Position the carrier and add 1 weight. Push the slider to the right, raising the incline slowly. Until the carrier starts sliding over the inclined surface. Then measure the run for trial 2. So let's expand the view so you will have a better view for measuring the distance from point A to point C. Now read the distance and record the run. If you need more time, you may pause this video. Now for trial 3. Position the carrier. Add 2 weights on top of the carrier. And slide the slider forward to the right until the carrier starts sliding downward over the surface. Now measure the run. So let's expand the view for better measuring. Read and record the distance from point A to point C or the run. If you need more time, you may pause this video. Now trial 4. This time, 3 weights will be added to the carrier. Just the same, you have to push the slider to the right until the carrier starts sliding down the incline. And measure the run. Okay, so let's expand the view for better measuring. If you need more time, you may pause this video. Now that completes the data collection for this experiment. Make sure that you have recorded all the dimensions and the measures for this experiment. For additional instructions, 1. Record the data. The mass of the carrier plus load, the mass of pan plus load, the rise, and the run on the tables in the activity sheets provided. Calculate the weight in dynes, the ratio of the weight of pan plus load, and the weight of carrier plus load. Show the computations. Calculate the ratio of rise and run. Find the average of these ratios and the percent difference. Show the computations. Answer data analysis, conclusions, and questions provided. Complete the report and submit to your instructor or professor. So before we end this activity, the author would like to acknowledge the physics department. For this virtual experiment was adapted from the laboratory manual developed by the faculty of the department. And the video in this activity presentation was taken from the video prepared by the following physics faculty: Professor Nelson M. Abana, Head, Professor Danilo B. Olete, and Professor Richard L. Muhi. Your participation in the conduct of this virtual experiment was appreciated. Thank you for watching this video. If you find this video interesting, learn the topic by watching this video, and believe that other students will also learn from this video, like and share this video. If you are new to this channel or have not subscribed to this channel, please do it now. Click the subscribe button so you will be notified of the upcoming videos. God bless, keep safe, and good luck.